You know those days where your tech just decides to quit on you? Your external drive disconnects right in the middle of a huge file transfer, or your mouse just starts glitching out for no reason. It is so frustrating. And, we usually blame the device. But what if the problem isn't the gadget at all? What if it's the power it's getting? What if I told you there's a hidden enemy in your USB ports and a simple way to see it? Let's get into it. Yeah, this is the big question, right? It drives so many of us crazy. You've checked the drivers, you've rebooted a dozen times, but the problem just keeps happening. Well, the real culprit might be something you can't see. These tiny, chaotic spikes and dips in power happening hundreds of times a second, right there in your USB ports. So here's the game plan for today. We're going to start by really identifying this unseen glitch. Then we'll look at a cool little tool that gives us a window into our system's power. After that, we'll decode what we're actually seeing, talk about the tool's limitations, which is super important, and finally, figure out its true role as that first big clue in solving these tech headaches. All right, first up, the unseen glitch. Let's talk about the symptoms of what a lot of techs call dirty power. It's basically an instability that can cause all sorts of chaos for our electronics. Does any of this sound painfully familiar? Your external drive suddenly disconnecting, maybe even corrupting your data, or your keyboard and mouse just acting weird and unreliable. These aren't just random acts of tech betrayal. A lot of the time, they are direct symptoms of unstable power delivery. So, this dirty power has a proper technical name. It's called voltage ripple. The best way to think about it is this. Your devices expect a perfectly smooth, calm river of DC power to work right. Ripple is like throwing a bunch of choppy waves into that river. It's this tiny, super fast variation in voltage that, while totally invisible to us, is just chaos for the sensitive digital chips inside our gadgets. So if this whole problem is invisible, how on earth are we supposed to find it? Well, that brings us to our next section. We need a window to look at that power. And luckily, there's a really simple tool that gives us exactly that. And here it is, the USB Ripple Tester. It's the small, pretty affordable gadget that basically acts as a little window, letting us peek into the health of our system's power, all without having to open up the computer case. It's literally designed to make the invisible visible. And how it works couldn't be easier. You just plug it in between your computer's USB port and, say, your phone or an external drive. It immediately starts showing you the voltage, the current, and that all-important ripple number. But here's the real magic. It's high-speed sampling. A regular multimeter is way too slow to see these super fast fluctuations. This little guy, though, it's built specifically to catch that hidden electrical noise in the act. Okay, so you've plugged the tester in and whoa, the ripple number is high. What does that actually mean? Let's spend some time decoding the ripples. And this is probably the most important thing to understand about this whole process. A high ripple reading is basically a check engine light. It tells you that a problem exists, but it doesn't tell you what or where that problem is. The tester has done its job. It's pointed you in the right direction. Now, the real detective work can start. So what are the usual suspects? Well, it could be your main power supply unit, your PSU, is starting to go bad. But honestly, a lot of the time, the problem's much closer to the port itself. See, the power for your USB ports gets filtered and regulated by tiny components right on the motherboard. If those little capacitors or voltage regulators are getting old and worn out, they can create ripple right there, even if your main PSU is working perfectly fine. But this brings us to a really crucial reality check. We need to talk about the limitations of this handy little tool, the promise versus the reality. As computer technician Dan Dewick puts it, when you need a truly reliable and complete diagnosis, the only way to go is with a calibrated oscilloscope. That is the undisputed gold standard for this kind of testing. The USB Ripple Tester is a fantastic starting point, but it is not the final word. Let's just break down the difference real quick. The USB tester is laser-focused. It only looks at the 5-volt power line for your USB ports. An oscilloscope, on the other hand, can test every single power rail coming from your PSU, the 12-volt, the 5-volt, the 3.3-volt, all of it. The tester gives you a simple good or bad number, but the scope gives you an incredibly detailed picture of the noise, its frequency, everything. It really is the difference between a quick screening and a full diagnostic workup. I absolutely love this analogy. Think of the ripple tester like a doctor's stethoscope. It lets you listen in, hear a murmur, and go, something's not quite right here. But the oscilloscope? That's the MRI machine. It gives you that high-resolution internal image that shows you exactly what and where the problem is. So let's bring it all home. In this final section, we're going to define the true and very valuable role of this tester in your toolkit. So here's the bottom line. The USB Ripple tester is an incredibly valuable first step. It lets you spot a potential problem super fast, without having to take your entire computer apart. Think of it as a practical, really accessible way to catch the early warning signs of failing parts. But always remember, it's an amazing screening tool, but it's not a replacement for a full professional diagnosis with a scope. And that's really the final verdict. For a technician who needs a quick check in the field, or for a PC enthusiast who just wants to keep an eye on their system's health, it is a fantastic, fast, and practical tool to have. It gives you the power to find that first crucial clue. So I'll leave you with this final thought. Your computer might seem like it's running perfectly fine today, but deep down, is the power that's fueling everything truly clean and stable? A simple tool like this might just give you the answer.